Today we're going to look at a neutralization reaction, which we learned about last semester when we were learning about types of reactions. And a neutralization is a type of double replacement reaction where you have an acid, here we have it symbolized by an HX, plus a base, and they react together to neutralize and create HOH, which is the same as water, plus a salt. This is very useful if we're trying to find, for instance, the molarity of an unknown solution. We can mix the known solution with an unknown solution until it neutralizes. And at that exact point when it neutralizes, then we can find the molarity of that unknown solution by using the volume that it took to neutralize the acid. There's a formula we can use that's very similar to the dilutions formula. If you take the molarity of the acid times the volume of the acid times the number of H plus ions in the acid's formula, that will give us the molarity of the base times the volume of the base times the number of the OHs in the formula of the base. It's helpful to write a neutralization reaction first just to fully understand what's going on with these. So that's what we're going to have you do, and then we're going to solve for the unknowns. In our first equation, we have sodium hydroxide, which is our base, and it is reacting, put a dot here after 20 ml to make it 2 sig figs, of hydrochloric acid, and we're trying to find the molarity of the hydrochloric acid. So our equation is hydrochloric acid, I typically write the acid first, plus sodium hydroxide. They are going to react to produce water plus NaCl. And these are a 1-to-1 ratio. So the number of H's in the formula is 1 and the number of OH's is 1. So to do our math, we're going to try and find the molarity of the acid, and we know the volume of the acid is 20 ml. And we know there is 1 H in the formula. That is going to equal the molarity of the base, which is 0.10 molar, times 25 ml. Now, even though moles is in moles per liter, we can keep this as milliliters as long as we have the same units for volume on both sides, because that will end up actually canceling each other out. So to solve this, we're going to do 0.10 molar times 25 ml divided by 20 ml, and that's going to give us the molarity of our acid, which is HCl. And our answer is 0.12 molar HCl. For our next problem, we've got 25 milliliters of a 0.020 molar potassium hydroxide, so that's our base, and we're using it to neutralize 15 milliliters of sulfuric acid. So sulfuric acid is H2SO4, so now we've got a diprotic acid. It is reacting with potassium hydroxide to create H2O plus K2SO4. And what you'll notice is that you're going to have 2 moles of your base reacting with 1 mole of your acid. And it may seem like it doesn't make sense to use the 2 from here when you do the math, but in order for it to work out, that is the formula that works out correctly. So if we have an unknown molar sulfuric acid solution, and it takes 15 milliliters of this, and we've got 2 H's in our formula, that is going to equal 0.020 molar base times 25 ml, and there's only 1 OH in this formula, and that's what we're looking at. We're not looking at the coefficient here, we're looking at how many OH's. So that is 1 OH. So we have 0.020 molar times 25 ml divided by 15 ml times 2 is going to be the molarity of our acid. And the answer is 0.017 molar H2SO4. Using the same procedure, you should be able to solve problems 3, 4, 5, and 6.